quick video on how to graph the sine function. We're going to start by doing the parent function, which is just y equals the sine of x. So in order to do this, we need to think back to either the unit circle or the table that we created with the various sine values. So what I'm going to do is I'm going to think about the critical points on that unit circle. We've got those 30 degrees, 45 degrees, 90 degrees, 180, and so on. I'm going to start by looking at 0 degrees. And if we were to plug in 0 for x, we would know that the sine of 0 is in fact 0, so we could plot a point at 0, 0. And the next point I'm going to look at is the sine of 90 degrees. So I can plug 90 in. The sine of 90 degrees is equal to 1, so I have a point at 90 and 1. If I plug 180 degrees in, I would get 0 again because the sine of 180 is 0. If I plug 270 degrees in, I would get negative 1 because the sine of 270 is negative 1. And then if I plug 360 degrees in, I get the sine of 360 degrees is also 0. So there I have all of my critical points. I can go ahead and sketch the parent function of the sine graph. Now, because the sine is a continuous periodic function, we know that it's going to repeat in the exact same pattern into the negatives as well. So here we have the y equals sine of x, which is the parent function for this, or the parent graph for the sine function. Now, if we wanted to do a more elaborate function, say something like y equals 2 times the sine of 4x minus 1, we're going to have to do a few different variations to this graph. The first thing we have to do is identify our a values, our b values, and our c values. So in this case, the a is 2 because the number in front of the sine function is 2. B is 4 because the number in front of the x is a 4. And c is a negative 1 because the number we are adding at the end is negative 1. What I want to do now is identify what my principal axis is going to be, which is the line in which the graph will oscillate around. In the original function, it was the x-axis. In this case, it's going to be y equals c, or y equals negative 1, since our graph is at, or since our c value is negative 1. So I'm going to go ahead and draw my principal axis in at y equals negative 1. So there's my principal axis. Next, I want to identify my maximum and my minimum. I identify the maximum by taking the c value of negative 1 and adding the a value of 2. So negative 1 plus 2 is 1. And then I identify the minimum by taking the c value and subtracting the a value. So negative 1 minus 2 is negative 3. So my maximum is going to go at 1, and my minimum would be at negative 3, which is a little bit off this graph, so I apologize, but we'll make it work. All right, now I need to identify the period of this function. The period is the distance that it takes to complete one cycle, which for the original parent function, we can see that it starts one cycle at 0 and it stops at 360. So we know that the original period is 360 degrees. So to find the period of this function, we're going to take 360 and divide it by the b value, which again is 4. So we do 360 divided by 4, which equals 90. So I know that for this new function, the y equals 2 sine of 4x minus 1, that my function is going to start at 0, 0 again, but now it's going to stop at 90 degrees. So it has to do this entire cycle that the parent function did, but in this short distance of 0 to 90 degrees. So I know that halfway between my start value and my end value, I have this point right here, that's in the middle, so I know I'm going to have another point right in the middle. But I'm doing all of this wrong because these should all be on the principal axis, which is down here at negative 1. So I apologize. We'll move these. So there I have my point on the principal axis where it starts, my point on the principal axis where it's going to stop, and right in the middle where it crosses the principal axis again. Now I know that my maximum is at 1 and is going to be exactly halfway between the first point and the second point. So in this case, it's going to be at, it's going to be right here, which is 22.5 comma 1. And then the minimum is going to be halfway between the 45 degree mark and the 90 degree mark, and at negative 3, so it'll be right down here. So here we have one cycle of the new function, and we can continue this function in both directions because it'll continue oscillating around the principal axis. Make sure that you remember that this is a wave or a curve, so the graph needs to be nice and smooth. It shouldn't be pointed at all. And if you look here now from 0 to 360 degrees, you can see that we've done 4 full cycles. That's because our b value is 4. So this is just a quick refresher on how to graph sine functions. It would be the exact same thing if we had said cosine, except the whole graph would look like it was shifted 90 degrees to the left.